Good morning, everybody, and welcome to the third workshop in this series. We have started this for now 2 weeks. So the first two were NSF, and then the next one was actually STEM that covered mostly NSF, but also DoD and others. And this is the third in a series on NIH. And the next one that's planned for next week would be on DoD. And then we'll see how it goes. If we want to continue, there is still a lot more funding agencies and other faculty members that could help us with other agencies as well. So for this one here, we have a distinguished set of faculty members. Three. They will help us to understand the funding with NIH. So these are Dr. Willie Wiggers. He's a professor in mechanical and aerospace engineering. And then Dr. Andrei Pakhomov. He's a research professor with the Bioelectric Center. And then Dr. Venkat Maruthamuthu. He's an associate professor with mechanical and aerospace engineering. So the format is simple, like we have done so far with other workshops. So each of these speakers, panelists, they will have 10 minutes. So they will present their perspective, and they have long experience with NIH, both as a recipient of funding and also as reviewers. And then after they finish talking, we'll ask a few questions, and then we'll open it up for the audience to ask questions, any relevant questions. So the way that we'll do that for the audience is the chat box, because it could be difficult if multiple people try to ask questions. So we'll have the chat box available for you to ask questions, and then we'll have the reviewers, the panelists respond to your questions. So let's get started. Let's have Willie, Dr. Wiggers, to talk to us first. Willie, please.
Okay, thank you, Con, for setting up this nice panel. I'm going to share the screen now. Right. So prompted by this opportunity, I actually took a look at the last 20 years of my funding record, and I compiled some numbers for you. And they were actually quite interesting, and they make a compelling point for what I'm going to say, because perhaps I'm a bit of a contrarian today, and I have certainly some opinions about the success rates that can be achieved, and also how useful it is to send in applications. And I'm trying to make some points based on those numbers in the following. So what you see in this table is that I basically looked at applications I put in the last 20 years to NIH and also to other agencies, both in the area of where I was an expert, sort of my bread and butter research area, which is on that column on the left, in the center, the middle column. And then the column on the right, these are areas where I was not an expert, or I didn't know the funding mechanism, or I didn't know the reviewers on the panel, okay? So the take-home message is that clearly in the area where I'm well known and I know all the reviewers and I have an established track record with prior work, my success rates are much higher, okay? So that's per application. So you see that with NIH R1 mechanism, I had 83% success rate, so 5 of 6 applications were funded. With other agencies like NSF, Sloan, Welsh, Human Frontier Science Program, and so forth, and private agencies, when I was younger, I sent in a lot of those, and so I have sort of a mixed record there, but the success rate was 9 out of 20, which is 45%. Whereas anytime I went sort of outside my expertise, or I tried some new mechanism that was not yet known to me, because maybe my program officer told me to do that, I had 0 success, okay? So I tried a couple of times, but it was basically not working out. So what that tells me is that it's very important to have already a standing in the community and established track record. And also NIH has been, to me personally, has been very good. Okay, so going to NIH basically guaranteed immediate success of my applications. So, you know, 83% is pretty high success rate compared to other opportunities. So going to the next slide, I hope this works, hold on a second. Yep. So I was looking at what attributes actually are most important, and that's of course very subjective. That's my own personal opinion. I learned how to write grants, NIH grants, as a grad student at the University of Illinois when I worked with Klaus Schulten on biomolecular modeling type applications. And you know, I later then continued with NIH because that's the area where, you know, that's essentially the agency that I knew best. So since I've learned how to write grants early on as a student already, as a PhD student, I kind of pretty much knew how to structure them. So the technical aspects were all taken care of. They were all well written. They followed the guidelines. They had good preliminary results. At least I believe that. And I understood the review process, especially at NIH. But I feel that these were necessary but not sufficient attributes, meaning that it's sort of understood at NIH that you know how to write a grant application. And certainly if your application is not well written technically, that will be used against you and you sort of be screened out. But even if you are writing the perfect application with the best you can possibly do, you spend a lot of time preparing it, it doesn't guarantee success, okay, as we have seen in the table on the previous slide. So what, in my opinion, predicts success better is that in the long term is that you establish a standing in the community. So you have to serve on study sections, you have to know your target audience of your application, who are your customers. And you also have to personally know the reviewers on the study section panel. So if you don't know about half of the people on your panel, you probably don't have the right panel to review your application, and I would be worried. So this is very important that you personally know people, especially on the review panel. And it's also, of course, to be well known, you have to be working at the forefront of an important field that NIH considers fund-worthy. And you sort of have to become an influencer. So I call, you know, in a way, so that's modern parlance from social media, but you know, you have to have some impact and people have to look to you as sort of a future leader. And that happens best when you're young and up and coming sort of investigator. And later when you're established, you can sort of draw from that impact and standing in the community. So this takes a long time to develop. And you can't just engineer that by, you know, making some small adjustments on the short term. So the only thing I found that can be done in the short term, if you're writing an application within the next year, is that you establish collaborations with heavyweight mentors, and you bring in collaborators that give you some clout in the community. Okay, so if you don't have any standing, at least bring in collaborators on your application who are heavyweights and well-known and have a clout, and then that will sort of impress the reviewers and make them less likely to ding you because they will not like to criticize some influential collaborators on your application, right? Because they have a standing in the community. So it's very important that you establish standing, and sometimes the best way might be through collaborators and mentors. So what I do is, firstly, I spent a lot of time on writing support letter drafts. So I spent about 70% of my writing time on a grant application actually on getting 20 letters from various collaborators and end users of our software, which is funded by NIH, just months ahead of before I even write the proposal. So that's very important because when you bring in heavyweight collaborators, maybe a Nobel laureate or two, or some, you know, some important people, they're going to be super busy and they're not going to have time to spend several hours on your support letter and to write that application for you. So what they do is they come to you and say, hey, can you just send me a draft, please, of the letter? And I'm just, you know, massage it a little bit and rewrite it, and then I sign it. So which basically means that you do 90% of the writing of your own support letters, okay? And so they still sign the support letter and might modify it if they don't like what you do. But the impact of your own drafts is very, very big, because more often than not, if a collaborator likes your draft letters, they will just adopt them, and that's what ends up in your proposal in the end. So it's very important to be very good at writing these drafts and using language that's different from one letter to the next. So if all your 20 letters read exactly the same, have the same phrases in them, and read like one person wrote them all, that's not a good idea, right? So you have to be very good at understanding what the collaborators actually would like to write themselves. So you write through their perspective, and you have to also use different phrases from one letter to the next, so your drafts are different from each other. So that's a little trick that I learned when I was a student, and later as a postdoc and as a beginning investigator, to make my application stronger. And that's certainly something people can adopt. And it's not widely known that this is important, but in my opinion, that's critical for bringing in heavyweight people, okay? What are pros and cons of going to NIH? With NIH, the benefit to other funding agencies, in my opinion, is that in applications, you often get very useful criticism because the summary statements are very detailed. However, there's a catch there. The quality of these reviews is only good if you're already an expert and are likely to get funded, right? So in that 83% part of my table, if you're in that 83% part of my table, then you get very good quality reviews, and they're very useful. But if you're outside of that, say you're writing outside of your expertise, reviewers might not always tell you really the truth. They might mask their identity and opinions by editing, in post-editing of the summary statement, editing out anything that's useful to you or can be traced to them. So if they're heavily criticizing you, they might just take out that heavy criticism and make it very boilerplate. So then you have to read between the lines or guess why they might not like your application. Very often it's that somebody is not an expert in the area and they just don't like it, and they're from a different field and don't care for it, and then they just ding you for it, and the quality of such reviews is actually not very high often. So it's kind of a mixed bag if you're outside of your expertise, and one shouldn't read too much into these summary statements from NIH if your application is sort of not a good fit, okay, as opposed to what I was proposing is to go into that 83% part of that table. So then the other pro with NIH though is that your ideas are relatively safe, especially compared to NSF, for example. So the problem I found with NSF is that they randomly send out your application to all your main competitors, and then you can, and since those you know, applications are being sent out anonymously, you don't know who gets your ideas. You can bet that all of your competitors will know exactly what you're doing. And if you get money or not, that guarantees that you get scooped within a year or so when you broadcast your best ideas to the community that way. That happened to me when I was a young investigator. I sent out an NSF proposal. And about a year later, I read papers by my main competitors that verbatim used the same ideas that I put in the proposal, and with about 1 year delay, okay? So clearly these people have read my obvious pandering going on. With NIH, you cannot influence program officers. They don't have so much power. It's actually the peer review and the scores they receive by other scientists that determines the outcome, which I personally like better because it's more objective, okay? Even though your program officer is still a good source of information about technical aspects. And the other thing with NIH is, in my opinion, it's a negative, is that these applications actually take a lot of work, takes about a year to prepare one really well. So they're not very suitable for a lottery or shotgun approach if you're an outsider to your field. So you have to really be very careful and measure your effort, how you invest it. So my last slide is then as the take home, my opinion, takes years of professional training to develop a standing in the community. And if you don't have a standing already, if you have as an investigator, you have no sense of belonging to your community and to a particular study section, you don't know where to send the grant, which study section is reviewing it. You have to ask yourself, what have you been doing in your career so far? Do you really belong there? Okay. So sometimes there's an explanation. Say somebody comes from Asia or from Europe to the United States and they don't understand the American system. So they're moving here from overseas, or a computer science researcher moves from outside of biology into a biomedical application. They might not be well established, or a young investigator. However, you know, I believe people need to be mentored and helped, especially young people. But in general, your odds are really against you if you don't have a standing, and you have to really overcome that. It's a big, you have to really put a lot of effort into your long-term development of your career and your standing in the community. So how does it square with what department chairs and college deans are preaching usually? So everywhere in the United States, you have department chairs and college deans. There's, you know, like 1,000 research universities or so. And everywhere I worked at 4 institutions in the past, department chairs and college deans preached the same sermon, that you're supposed to send in many applications and try the shotgun approach. But I personally don't like this lottery application approach, because it's very frustrating and wastes your time. And as I mentioned, with this NSF experience that I had, that the odds, since the odds are sometimes against you, you can also get scooped by your competitors while you're spending your valuable time on application writing. Your competitors run away with your best ideas and scoop you, okay? So it's much better, in my opinion, to actually do research and write publications very quickly and stay ahead of your competitors than to send in too many applications and waste your time with them. So try to be in the 83% part of my table, not in the 0% part, okay? So with that, I would like to say send in fewer applications, but only those with highest chance of success, okay? That's my take-home message. Thank you.
Thank you, Willie. All right, so we'll move to the next speaker, and this is going to be Dr. Venkat Mulathumuthu from Mechanical and Aerospace Engineering. So Venkat.
All right, so I have much less experience working with the NIH, but I have more experience with the NIH than, say, NSF or any other organizations, and I've had a good experience with them as well. So I would like to basically give an overview of NIH research funding, keeping in mind some of you who may not be familiar with the NIH, but also talk about my experience where applicable. So of course, the key distinguishing feature is that NIH funds health-related research. So at the outset, when you have an application in mind, you want to ask whether it's really health-related or not to help you target, say, NSF or NIH. So NIH is really an umbrella of like 27 institutes and centers. I think 24 out of those 24 fund grants. And one of the things with NIH is when you look at the literature on NIH online and so on, there's a lot of abbreviations and jargons used. So it helps to get familiar with this jargon. For example, institutes and centers are called ICs. So you want to target your application to the right IC. So initially when you're trying to figure out where to submit it. For example, I submit my applications to the NIGMS, which funds more basic biomedical research. And again, each institute has many divisions, and each of those divisions has many branches. So I submitted to, for example, the division of cell biology, and I think the branch was biophysics related stuff within NIGMS, right? So you want to first make sure you're targeting the correct IC in your application. And the funding opportunity announcements or FOAs, are of many types within the NIH. So again, you will see this lingo, the abbreviations, PA, RFA, etc. RFA, request for applications, may mean something in the context of some other organization, but for the NIH, RFA refers to a very targeted area for which they have set aside some particular amount of money. PA is, or program announcement, is something that's broader, but they don't have any fixed budget set aside. But for our purposes, I would say the last one, called parent announcements, are the ones that are investigator initiated or unsolicited, meaning they didn't ask for any particular area to be investigated. It's your area, whatever you can contribute in. And so you send in your application for a parent announcement. So R01s that Willie was talking about, R15s, which I have experience with, R03, R21, all these come under the umbrella of parent announcements, where there is a standard announcement, standard 3 cycles per year, you can send in your applications to. Coming to the actual application, NIH application, the first thing I would suggest is to carefully read the FOA, because what I have found is within the FOA, they clearly tell you what they're looking for and what kind of things to address. For example, alternative approaches and so on, which you're supposed to specify in the application. And so if you look at these keywords in the FOA, that essentially suggests to you that you can have subheadings within your application where you specifically address those things. And typically reviewers deal with many applications. And so if you actually have these subheadings that address everything that's asked in the FOA, they can directly look at that and pull it out when they're discussing your application. So essentially check all the boxes. So that's the basic, right? Once you do all this, still there is no guarantee of funding. But if you don't do all this, then you're at the outset starting with a disadvantage. So with the application itself, essentially 3 things: sound idea, it should be credible, presented with clarity. Right? By sound idea, I mean something that is clearly important in the context of NIH, in the context of the IC that you're submitting it to. If the fundamental idea that you're addressing itself is not so important, it's been done before, and so on, then no matter how great the writing is, it's really going to be tough. But if the fundamental idea is really good and important, that really energizes the reviewers into actually dig into the application and actually evaluate it better. When I say it should be credible, essentially, you need to have good preliminary data, if at all possible. Even if you don't have direct preliminary data, you want to have at least related preliminary data that can be adapted for that application. If you have publications in that field, you want to highlight, in that specific area, you want to highlight it so that they can see that you are credible. They should be confident that you will be able to do the work. Because one of the common critiques that I've seen is, we're not sure if the investigator has experience with this technique or things like that. So you want to show that it's credible. And by presented with clarity, I mean, use a lot of graphics where applicable and present it in a way such that the reviewer has an easy time identifying the different aspects. Each aim, it's better if it's presented as a hypothesis, and the aims should be related to each other in a certain way. Sometimes if it's too interlocked, it can be a problem in the sense that if aim 1, the result is not what you expect, even then you should be able to do aim 2 and 3. So there should be some flexibility, but at the same time, there should be a tight relationship between aim 1, 2, and 3, and so on, so that the application seems coherent. Right? So for those who are applying for the first time and so on, you have to note that there are some administrative requirements For example, you need to have an ERA Commons account and so on. So this is basically a website that deals with grant administration. But for the first time, if you want to set it up, it takes a few weeks. So you have to think ahead, at least several weeks, right, for such matters. In terms of contacting the program official, I think the terminology is program official or program director. I've seen both these terms used. So contacting the PO becomes more important if you are not too familiar with NIH or that particular institute and so on. But if you clearly know what you're doing in terms of targeting the IC and so on, contacting the PO is not essential. For example, the first time I applied and was successful, I didn't contact the PO because it was really clear to me which institute would be applicable for my case. So it depends on your particular situation. So you would contact the PO before you submit the application. The other time you would contact the PO is after your application is reviewed. So after the review of your application, depending on your score, which we will look at in the next slide, you may want to talk to the PO, especially if you're in the gray zone. Right? So coming to the review of the application, once you send in your application, there is the Center for Scientific Review, or CSR, within the NIH that actually receives the application and then sends it to the correct IC and study section. So study section is the term used for the review group that actually reviews your application. And many study sections usually are part of an IRG, or integrated review group, right? So the study section actually reviews your application, and the roster for the study sections are available online. So you can see who's in the study section, and you can probably guess which few people are likely to review your application as well, based on their expertise. Usually, there are 3 main reviewers who actually go through your application in detail. First 2 of them are kind of closely related to your proposed area. The third person is sort of related, but somewhat removed. So usually the third review is typically a bit shorter than the first 2 reviews for that reason. And the person who manages the review is the SRO, or Scientific Review Officer. If the institute or center IC that you directed your application to is not the IC that was assigned, then you can contact the SRO and see if it can be changed and so on. I'm not sure how flexible they are and how easily it can be changed, but the SRO is the person you contact in case there is some mismatch in the study section or perceived mismatch in the study section. The actual review itself, for those who are familiar, is based on 5 criteria: significance, investigator, innovation, approach, and environment. Based on my experience, what I've found is that for the environment factor, ODU is viewed favorably as long as you have all the elements in your application that highlights the strengths of ODU with respect to this application you're submitting. So as long as you show that you have all the resources you need to carry out your research, I've found that they are usually quite supportive in grading the environment. The significance innovation approach entirely depends on that particular application. So it's basically up to us to highlight those aspects within the application. Again, investigator criterion, it comes to what Dr. Riggers was mentioning. If you have performed research and if you have a track record, this is much easier to score well on this particular criterion. So it's always a good idea to get 1 or 2 publications in that area, target good journals and so on, so that you can take care of that particular criterion. So the way they score the application is for each criteria, each of these 5 criteria, they give a score from 1 to 9. And then based on the whole assessment, each reviewer gives an impact score that varies from 1 to 9. importantly, this impact score need not be just an average of these 5 criteria scores. It can be totally disjoint from that, but it is informed by those assessments, right? So 1 is the best, 9 is the worst. So each reviewer gives this impact score, and then my understanding is that all the reviewers give an impact score, and the mean or the average of all of those multiplied by 10. And so it varies from 10 to 90. That's the overall impact score or final impact score. And so you would get this overall impact score as long as your application is in the top 50%. If it's in the bottom 50%, you will still get reviews, but you won't get this impact score. So if it's in the bottom 50%, it's not discussed, or it's also called triaged. So if it's triaged, you would still get reviews, but you won't get the score. But if it's in the top 50%, you would get an overall impact score. And what score is fundable varies from institute to institute. So if your overall impact score is, say, 15, you're much more likely to get funded than if it's 35, right? And one of my applications scored like 40 or something. So it's really a coin toss. If everything else works out, there is a small chance you'll get funded. Otherwise, you will have to put in a revised application and so on. And so the final aspect of this is once you get your
balance. And if the proposal is not really interesting, if it is not exciting, you do, well, I cannot say for all reviewers, but it is often just a formal review. However, if you manage to raise the enthusiasm of a reviewer, then they will read further. They will look at more criteria. So how to make them excited? First of all, you should be excited about your research. And your excitement, you should convey to reviewers. If you are bored with what you propose, they will be bored as well, no matter how good your science is. So the specific aims page for NIH, I think the main part of the proposal. And from this single page, which reviewers usually start with, they will decide whether the proposal is potentially interesting or not. So the specific aims page is something that sets the reviewer's enthusiasm at a certain level. If it is low, then he or she will just find what is wrong with the rest of the proposal and move to the next review assignment, in my opinion. If the enthusiasm is set high after reading the specific aims, then the situation is different. Then the reviewer will really read the grant attentively and evaluate it more seriously. There will be points which increase the enthusiasm and points which decrease the enthusiasm. So the final level of enthusiasm is the decision, how high the score should be or whether the proposal passes or fails. So the specific aims page determines if the grant has a chance or it does not have a chance. Hence, this page should be made perfect. There are no shortcuts, no, it should be full clarity, very logical, clear outcomes. And the research strategy is the next most important section. If you have excellent environment, investigators, etc., 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 but if the research strategy is vague or unexciting, the rest doesn't help. The enthusiasm will drop. So your approach is by far the most important criteria which affect the score. The excellence in the other categories, not in the approach, it will only have the meaning if your approach is excellent, if the reviewers are enthusiastic about your approach, if you have great environment, if you, well, have great publications, etc., etc., still, if your approach does not excite the reviewer, it does not go anywhere. Speaking more about the research strategy, there are several features which are important. The integrity. There should be a clear goal, and this goal should be of interest not just to the investigator, but to a broader community of scientists who may work in different areas. This is particularly important if you work in a relatively narrow area. And example is our nanosecond pulsed electric field. It is very narrow. And if the work is only of interest to these people, maybe of very high interest, it will not make it through NIH. You should show either applications in different areas, or you should show why other people may be interested in your findings. Maybe you propose a new research technique that they can use somewhere or solve the problems which could not be solved without it. And yes, with the proposals I made to NIH, I always had to make it into the areas where people never heard my name. And it is difficult. Sometimes they really don't want to look at proposals coming from a different area. They never heard of electric field. For example, there are radiation therapy panels, and they do ionizing radiation, and they don't care of anything else. They don't want competition. Still, if you make reviewers enthusiastic, you can count on them to be your advocates. Then back to the research strategy. So the specific aims should get to the goal which you set in the approach, and it should do it step by step. Maybe you should approach it from several different directions. Always try to use best approaches available today, rather than trying to save money. Reviewers don't like when you say, well, we want to make it cheaper, we save money. No, use the best approach. Even if it costs money, well, don't go through the roof. Be reasonable, but if you use outdated approaches, outdated technique, that's not going to be good. Research proposals should always be a coherent story, and coherent and exciting. And there should be a flow. It is a story. That's something that people often forget. And as in every story, there should be intrigue. And that's what makes it people, reviewers, enthusiastic. Contingency, that's something that the previous speaker mentioned. If your specific aim 1 fails, what do you do with specific aim 2? And this is often very difficult to address, and really what you want to do next may depend on what you have done previously. But this is a common failure, and reviewers say, what if? And you have to answer that question. What I have seen a lot, many people write a grant as if they are doing a favor to the funding, to the granting agency. And this is a big mistake. And don't make the reviewers work harder than it should be. Don't expect them to Google to find something that you may know and they do not know. Don't expect them to look at reference papers, that they have better things to do with their time and with their life. Only if you already raise their enthusiasm level very high, they can do it to help you out. But other than that, it is up to you to write the very best proposal possible. If you are not satisfied with what you have written, then don't submit it, just wait or polish it more and more. And a little bit about the style and what you write, bragging in your resume or anywhere. Just state the facts. Leave the judgment to the reviewers. Never say we got interesting results, because interesting is not something that you can measure or you can prove. And it may be interesting to you, and it may be not interesting to reviewer. Or don't say we have exciting observation. Instead, describe what makes you think that it is interesting and exciting. Maybe it was cited by 200 papers. Maybe it became a topic of a special session. Maybe it is something really unexpected. Never say that I made an excellent study. This is again your judgment. Instead, provide facts. Make reviewers judge if this was an excellent study or not an excellent study. And there are some phrases I would suggest to avoid, even in recommendation. I don't know how to call it. I would call it enhance judgment words, like say a significant advancement. Don't say so. Advancement is good enough. You can say clear passion. Passion. Okay. Great leadership. Leadership is okay. Don't make it great, or clear capacity or significant skills. Skills is good. Don't do it significant. And in general, make your proposal concise. Remove any extra words and unnecessary qualifiers. If you call your collaborator an internationally renowned expert, think about it. If it is renowned, well, then of course it's international. So international doesn't need to be there. If a renowned expert, well, if the person is an expert, then it is an expert. So renowned is not needed either. So just leave the expert and leave to reviewers the judgment whether this person is an expert or whether he or she is renowned or not. So that's probably all I wanted to say today. Thank you for listening.
Thank you, Andre. Thank you, all three of you. So what we have heard from all three speakers are different perspectives, right? And some of these not just relevant to NIH, it could be actually applicable to any application that we send out to NSF, to other funding agencies. Of course, majority or most of it was about NIH. So thank you again. So let me now move to the next part, which is I'll just ask maybe a few questions, 2, 3 or so, just to get the discussion started. So in the meantime, I would ask the audience, please go to the chat box. It should be available to your window for Zoom, and ask questions. And then we'll take those questions and ask the panelists to respond. So I think three of you combined, you pretty much covered most of the details for NIH application. I was thinking about this separation between review and the funding for NIH, which is, I think, as far as I know, is perhaps the only agency that does like this. If you could expand that a little bit for those of us who may not have experience, and how to deal with it and how to understand that process.
Should I start?
Yeah, sure.
Okay, so this is a very good point that I didn't, clarify in detail, and was later brought up by Venkat and also Andre. It's what is the success rate after the review based on your score? So you have to understand there's some sort of there's an S-shaped curve, and depending on your score, the program office actually and the council do have some influence on whether you get the funding or not. So if your score is super high, you're guaranteed to get funding. And it's also, if it's super low, you're not going to get funding. But since there's this gray area in between, somewhere between, it goes by percentile, somewhere between 10th percentile and 30th percentile, there's this S-shaped distribution. And sort of NIGMS, which is my institute, the sort of the 50% mark is sort of at 20, a percentile of 20. So if you're better than 20, you're more likely to get funded. And if you're worse than 20 in terms of percent, proposals up into funding range, and likewise they can ding some people who already have a lot of grants and don't really need another one. Okay, but we're talking here about young investigators at ODU who are likely to, for the first time, make an application. So we would all fall in the category that NIH actually would like to support because we don't have NIH funding yet, or maybe it's our only grant. If we lose that grant, we're going to be out of business. So these are at-risk investigators, what they call at risk. So most of us are at risk or young, and so we're actually being helped by our program officers. And even if you score below that 20th percentile, they might actually lift us up. So that's really good news for us at ODU, okay, that we're being helped by that mechanism. Of this, and do establish a relationship with your program officer, because that might be the difference between funding and not, especially when it goes to a council meeting.
Go ahead.
To add what Dr. Ricker said, so the overall impact score is something that the study section assigns to your application. But as he said, based on the impact scores, the percentile score is calculated, meaning there could be a study section that is hard on all applications and all impact scores are worse, right? But there could be another application, a study section which goes slightly easier on all applications. So to normalize for this, what they do is they take the impact scores of that study section over the last 3 cycles, and they convert it into a percentile score for that study section. So in that sense, you have a percentile, and based on the percentile, many institutes actually have a cutoff or a pay line for which percentiles they are likely to fund. NIGMS is, I don't think it publishes a pay line, only because they take into consideration some other factors, even more so than other institutes. And the other thing which he mentioned was the new investigator or early stage investigator status. So if you got your PhD within the last 10 years, then you're an early stage investigator or ESI, and that gives you a slight bump in your likelihood of funding. In the same way, you're a new investigator if you have not held an R01 level grant so far. In that case, also you get a slight bump. I think the ESI bump is much more significant, but still, you take everything you get, right? So essentially, the percentile is what determines the pay line in most institutes.
Thanks.
So thank you. Very quick response to this. Yeah. My numbers are, these unofficial numbers I mentioned are from my program officer, okay, regarding NIGMS. So that S-shaped distribution, that changes from year to year based on their budget, but it goes about from 10 to 30 percentile.
Right.
And do you want to add something, or we can move to
yes,
next?
I can add just a little bit. This sliding scale that NIGMS has had for many years, other institutions are mostly partially adopting it. The program officer usually has a lot of power, I would say, or a lot of decision making about the gray area proposals. And NHL heart and lung institution, for example, the program officer may decide that this and that proposal, which are above the pay line and should not be funded, but the program officer can argue for the council and say that this is of high interest to program officer and it will get funded. So program officer, they can arrange their portfolio of studies according to what they want. And sometimes you get even unexpected funding, because there was a situation when I was above the pay line. So I did a resubmission of the proposal, and when it was resubmitted, I got a call from the program officer. He said, do you want your previous proposal funded? And it was actually submitted over a year ago. And I said, well, why can you do it with my new proposal? It is better, I think. He said, no. It is either your previous proposal or we can go with the new review on the new proposal. No, thank you. Give me just the previous one, even though the new is better. So my point is that program officer has a lot of power to help you or not to help you. So that's it. And also, I just want to say that I'm sorry I need to leave. If somebody has questions to me, please contact me directly. I will try to answer. It was nice to attend here.
Thanks, Andre, for making it to work and come here and talk to us.
Bye.
Sure, bye. So we still have 2 more panelists left, and if you are interested, NIH. So if you, one of you or both of you, can expand on that, and how to really make it look like you are working with them and they are actually part of the proposal, not just add-on.
Okay. So as I mentioned, it takes several years to build established relationships, and you typically have to have some papers already to prove, so your case. So when I have collaborators, they usually list joint publications with me in their letters. So there's already some established track record in many cases. And if it's a new investigator I haven't actually published papers with, at least they tell me what data they have and what we have done with them. But usually reviewers really like to see already existing collaborations where you actually have worked on their data already and done something with them that is meaningful, as opposed to just proposing something for the future that is not, where it's not clear what the credibility is. Because many people can just write something, right? But whether you actually follow up is another story. So it's good to have some, pre-existing results that you can write about in that letter.
Yeah, my experience is in terms of collaborators in general. So I'm not sure exactly what clinical collaborators really refers to, because there are different types of collaborators you could have. But if you're having a collaborator, maybe a clinical collaborator, depending on your research, you want to make sure that it is the collaboration seems organic, right? If it's like an add-on, my impression is that reviewers will easily see that, and it might even become a negative. So to actually put in some groundwork to make it more coherent. Otherwise, you may as well go solo. Like my application, I submitted myself because just based on my research and my situation, I did not have a collaborator in mind who would go well with the application. So I just tried it myself. So so I think it entirely depends on your particular area of research, just that it should require some groundwork.
Right. Thank you. Yeah. So like you said, both of you, it really depends on your area of research. In some cases, for example, your collaborator could be from somebody in statistics for data analytics, for example, right? So there are study sections. If you do not have a person who does in biostatistics, the research, you could be actually in trouble. So it depends, right? So thank you. Here we have a question from Krishna. The question is, what type of grant submissions should be targeted by engineering faculty, given that NIH is focused on health-related proposals or proposal ideas at the intersection of engineering and health clinical?
I tried to answer that in my presentation, that it's very important to have that you're part of a community. That means you're going to biomedical or biophysics oriented meetings. You know your target audience, you know who your customers are, you know who's benefiting from your research and what questions you want to address. And that sort of dictates the meaning of your proposal. So engineering in a way is used as a set of tools towards you know, solving a particular research problem that's biomedical. And so you really have to do the hard work and actually go to these meetings and establish a relationship with investigators there, and also be a speaker maybe and publish some papers in those journals to become a respected part of their community. I don't see any other way as an outsider to break into that circle otherwise.
I would say that the fact that you are in an engineering department should really not be a disadvantage, as long as your research can fit into an IC's mission, right? So, like I said, there are many institutes within the NIH, and there are several institutes which might potentially fund your work. The best way to check that is if you search for NIH Reporter. So that's a website that has, you know, where you can search all the proposals funded by the different ICs. So if you just Google for NIH Reporter, you'll get the website, and there you can actually look for it. So this also addresses the next question from Sharon, which is sort of related. So if your particular area, if you want to see if the NIH funds it or which institute funds it, go to NIH Reporter and check out different institutes and check out different keywords and see what proposals have been funded. And the best measure of what can be funded is what has been funded recently. And I think that should give you a good idea.
Right. Thank you both. In fact, the question that Sharon asked was, how would NIH perceive health research in extreme environments? Example, space environment on the surface of Mars. Would they be interested at all? So yeah, thank you for addressing that, Venkat. So essentially, like any other funding agencies, you need to spend some time on their webpage. That's the bottom line, right? Look at the different ICs, what kind of funding and what kind of topics that they are interested in. And so another related question, a little bit different, I guess, is if you want to serve on a panel, who do you talk to? So for example, NSF, you can talk to the program manager or program officer. In this case, who do you talk to if you're interested?
Well, they usually come to me. I mean, it's not something I like to do because it's actually a lot of work, but it's necessary and it's a service to the community, you know, honestly. And I get invited to a lot more review panels than I can handle. And so I have to turn them down a lot. And so I feel it is important to do because you have to know people on the panel and establish a relationship and be a good citizen. But you know, if you're young, I don't think you're expected to be so super connected that you're already serving on panels, because I think young investigators, they want them to do actually research and develop new research ideas, and they don't want them to spend their time writing books and serving on, you know, what established investigators do, senior investigators, the types of things. Young investigators shouldn't spend their time writing books and serving on enormous amount of panels. It's not good for their career because they don't have the time for research then, you know. And so it's okay if you're new to a field and if you're young that you don't serve on these panels, but you still need to know these people though. And how do you get to know them if you don't serve on panels, right? That's a difficult question to answer. So the best is to actually look at the study section rosters and from previous meetings and see if there's one that where you recognize people. Or alternatively, I would go to meetings and talk to investigators don't listen to just the talks and presentations, but after the talk is over, you pick the speaker and talk to them in the hallway about their research ideas and where to get funding, and introduce yourselves and make yourself known. That's actually more important than the presentation they give, is what kind of insight you can get from them about funding mechanisms at meetings. So it's very important, in my opinion, to travel to conferences, which is of course hard to do right now during with our lockdown and the COVID situation that we have at the moment. But I feel in the past that has helped me a lot, is to connect to a new community. So Bakan, you have also really good experience as a computational person to break into NIH, right? Maybe you can tell us about your experience also, because I'm curious myself how you did it.
Well, this was not about me, this was about you guys.
Yeah, no, but we have now only 3 panelists. Maybe you can, 2 panelists, so you can be the 3rd one.
Right. So in fact, like both of you, or 3 of you, all 3 mentioned, in the beginning, I spent quite a bit of time looking up the different programs. What do they fund? What are they interested in? And then my research was actually in DoD, mostly in the beginning, but it was computational research, right? So that's what I wanted to see if NIH would be interested. And then looking up those pages and then going to the conferences like you suggested, and meeting those people and listening to their presentations. And then meeting the program managers on the sideline from these conferences and talking to them and understanding what do they really want to fund, or if they want to fund anything like what I do. So all those, so that took me a couple of years actually before I got to break into NIH. I would say a good 10 years or so it took me to understand the culture and the whole idea of how things could work for NIH. So it is really a good hard work that everybody has to do. I think there's no shortcut, if I understand correctly, like anything else. So one other point, and I'll let Venkat also chime in. For NIH, the difference also I think is with this separation of proposal review and proposal funding. So the review is completely done, like I think one of you mentioned, is by the CSR, Center for Scientific Reviews. And that's a whole different organization. They have nothing to do with funding. All they do is just review of the proposals. And in fact, you should spend time to look up this CSR and understand how they organize themselves. What are the study sections? What are the people and who does what? Because that's also a very good insight that you should have, because that's where your proposal will end up to when you send a proposal, right? Sometimes you can even request that my proposal should be handled by a specific study section, because sometimes it may be on the borderline. They may not know exactly where to put it, but you know some people that are in that study section. And that's also brought up by the panelist earlier, that unlike NSF or other funding agencies, here the reviewers are all published. You can actually look up the roster that Venkat talked about. So you can look up, they usually meet the standing panels, that's what they say. They meet 3 times a year, right? So you can look up all the people who had served on that panel, and you can look up who would be relevant to your area. And that's where you would like to submit your proposal to, or you can even write a letter asking or requesting them to submit, assign it to that study section. So that's how I think is the starting point for you. And then from there, once it receives a good score, again, expanded by the panelists earlier, then it ends up to the programs. And that's when the program manager or the program official becomes really important. Even if your proposal does not get a good score, still you can talk to your program official afterwards and understand what could be or what ideas could be there to improve your proposal next time. One other point I would like to mention here, that NIH gives you at least 2 chances to resubmit, right? Explicitly. And in fact, the second time you submit, it used to be 3, now it's 2. Second time you submit, you're required to submit 1 page of how you addressed the reviews from the first review, right? And that is really good because it keeps the continuity, and chances are it will end up to same reviewers, or at least to the same panel, right? So that is to your advantage. So that one page that you write for the revision is really the most critical part for the second submission, because that's where you can actually write a convincing response to your submission. That, okay, here's how I took care of all the comments. And if you can convince in that one page, chances are you're going to do really good in your second submission. So Venkat, if you want to add something more, or Willie even.
So with the review, serving on the review panel, the only thing I wanted to add was NIH has a program called the Early Career Reviewer Program, or ECR program, which means they are actually actively trying to recruit the junior folks in review panels. At least they have a program for it. So if you just look it up and then contact, whoever's listed in that website, I think it's worth it. It's worth trying to serve if one is interested.
Right, and in fact, that CSR that we talked about earlier, all those people who manage the reviews, you can actually write to the person who's in charge of that panel. And those are all available on that website. Their emails, names, everything. So you can just request that I would like to be able to serve on your panel. Right. Is there any other question? I don't see any other question on the chat box.
I have a quick comment to this, Wakan, what you just said. Now, I don't have a lot of experience with second submissions, but I'm in a different situation because people expect from me that, since I've been in the field since I was a student, right? So they expect from me that that I do it right the first time. So either people love my applications or they hate them and they shoot me down. So I don't usually do second applications as much, but I think second applications can be a good mechanism for people who break into from another field into NIH the first time, because it really helps you address these points that you mentioned. You don't get that benefit really from the community if you're already established. They just either destroy you in the first review and you give up, or they love it. I'm usually very enthusiastic based on what Andre said. That's a very important point, to be very enthusiastic, but that doesn't always mean that the reviewers are as enthusiastic. So usually I'm polarizing. Either reviewers like what I'm writing or that they hate it totally. And then there's no in between, and I don't do second applications, but that might just be me. And that also shows you that you can have diverse experiences at NIH. If you do it for the first time, like as an engineer, you might benefit from some mechanisms that I never got to explore because I have a different upbringing, sort of. You know what I'm saying? So it really depends on your personal situation, what works best for you. So you should not accept everything we said as the truth. What I said in the beginning was very subjective, and that might not apply to other people.
Right. Thanks, Willie. Yes. In fact, all of these things we are talking from our own experiences, right? And everyone's experience is different. But there are some commonalities, and that's what we're trying to bring out in these discussions and panels. So yes, please take it from that perspective. All right. I do not see any other question on the chat box, but if anyone has anything else to ask, please do so. It's a little bit difficult from engineering background unless you are, like Willie said, sort of in the domain and has been sort of brought up in this area of research that is relevant to NIH to get funded from NIH, unlike, for example, NSF or other agencies. We're sort of, as engineers, kind of aligned to those other agencies better than NIH. So it will take some deliberate effort for somebody like me, for example, to break into this agency. And that's why you need to be around to that type of people, perhaps clinical people, to sort of understand. And that's another thing that took me quite a bit to really understand the clinical perspective. And how do I talk to their language, not just my language? So those are the things that will take time. On the other hand, I think if you persist, like anything else, it is doable.
Good.
You want to add Venkat or Willie on this?
I mean, one thing I wanted to add was I have had more applications not discussed than discussed, yet my impression is that the NIH review quality is really good. And as long as you see, what the drawbacks are and correct it. So there's, like Dr. Khan said, there's one resubmission opportunity. If that doesn't work out, you wait 3 years for it to be considered a new application again. So you can propose different ideas, modifications, and so on. But my impression overall is that the NIH review process is really good quality, and it sort of brings out the best science most of the time, right? So that's something I want to just add.
Right, thank you. And in fact, while you're talking about the review panels, so NIH uses 2 types of panel members. One are in fact panels as well. For panels, they have these standing panels, meaning these are repeated 3 times a year, right? So the same panels meet. And in fact, your application may be funded by NCI, Cancer, or Aging, or some other agencies, but the similar thematic or themes proposals are brought into the same panels, right? So that's one type of panel. The other panel that they have is ad hoc panel. So depending on what they have received, they may not have a specific panel for that topic. These are sort of new topic, or sometimes may not have too many submissions. So that's when they do these ad hoc panels. And those panels are still published, but not, they don't meet on a regular basis, 3 times a year. As for the so there's as for the reviewers, that's also 2 types. There are 2 types. One is you could be a charter member, which is like a standing panel. A permanent panel will recruit you for 4 years. So that means you will be asked to review 3 times a year as a charter member, and you will be expected to participate. Of course, sometimes you may not, that's fine, but that's how it is. And then there is this ad hoc reviewer, right? Each panel will also have ad hoc reviewer. So usually about 60-40, 60% charter members and 40% ad hoc members. So that's where you can just ask yourself to be included as an ad hoc to start with. And usually they don't appoint you as a charter member. Charter member is actually, it's reviewed. It has to be approved at different levels, all the way to the head of the institute and things like that. So that's a difficult process, and it happens later on in your career. But ad hoc is usually easier to get into. Okay, I do not see any other questions on the chat box. It's about 12:20. So Willie and Venkat, if you would like to add anything else before we finish.
Okay. There was this point before about the merit of attempting a new review, and I didn't want to be too negative on that. So a new submission. I had sort of mixed experiences at some panels. So I think the ones where I didn't have the best experiences at NIH was with ad hoc panels, because they tend to be, you cannot predict who's on the roster often. You don't know the people, and it's already bad news, right? If you don't know who your reviewers are. And so that's very hit or miss. Whereas with standing study sections, where there's a long established record of charter members that you personally know, I had much better experience. But it might not always happen in your particular field that there is a standing study section. So then you have to contend with ad hoc. But ad hoc is sort of falls more into sort of this lottery approach that I mentioned earlier. It's hit or miss, and you don't know what you're getting. And I also found that sometimes the reviewers might not be in your area of expertise, and then the quality of the review is not the best. So it doesn't, overall, I agree with Venkat that the quality of reviews is good at NIH, but it's kind of inconsistent, depends on how well your particular proposal matches the already established funding mechanisms there. And if it's just not a good match, or if it's some random study section, it's kind of, you're a bit out of luck, you know. That can happen. And then also often the reviews are not very good. So you should not overinterpret them, because sometimes they get really, it can really disappoint you and set you back and discourage you from doing the research, because you might get some really, you know, negative review that you don't understand even where that is coming from, and it sort of puts you down. But then you take the same application, more or less without changes, submit it to another study section, and all of a sudden you get into funding range with your scores. So that shows you a lot about the randomness of that mechanism, right? So there's a certain randomness to it. Perhaps that's sort of also what I want to say at the end. You should expect that and not overinterpret negative results and let that discourage you.
Yeah, to add what Willie said, when you get the reviews back for your proposal, look at the common denominator, and that's probably the thing that you should address more importantly. Once in a while, the reviewer, based on their particular, you know, idiosyncrasies, may say something which may not be really something you need to fix. So you look at what's common and address that. That's you know, gives you the best chance of success.
Thank you both. Let's thank the panelists and wish we could do this face to face, and we could all enjoy your company together. But thank you so much for making yourself available and spending some time to help us and help the college. So the next week, Tony, I believe you're still around. If you want to go ahead and announce the next panel, DoD.
Yes, we're going to be doing a panel about DoD funding next week. Right now, we're waiting on a couple of the panelists to commit, but as soon as we get that commitment from them, today or tomorrow, we will send out the announcement. So same place, same time next week.
So hope you'll be able to make it. Sorry, Tony, you wanted to say something else?
No, I'm just saying, if anybody has any questions or suggestions for future panels or forums, please email Con or myself so we can get those together.
Right. Yeah, we're in fact very interested to hear from you feedback. So far, feedback that you have gotten, all those are very positive. People are talking good things, but we'd like to hear from you so that we can decide if you want to continue this. Like I said in the beginning, there are many other funding agencies and other successful faculty members who can share their experiences for others to benefit. But we'd like to hear from you, so please do. I guess with that, thank you so much again for everybody coming and listening to this workshop, and hope to see you again next week. Thank you all.